Hey everybody, we are going to talk today about modeling randomness and if statements in Python. So we're still talking about modeling a bike share, where we're sending bikes from place A to place B and place B to place A. And what we want to add into our model is the idea that when you leave the house in the morning, it's never exactly perfectly well known, right? Maybe uh, you wake up late, maybe uh, the shower takes longer to warm up, maybe your toast burns and you have to make new toast, or maybe everything goes completely smoothly. There's some randomness involved in when you leave the house. And so there's going to be some randomness in terms of when people take bikes and how bikes travel from one place to another. Um, so we're going to use uh, Python to simulate this randomness. Um, so we're going to model it. We're going to use the flip command. All right, and so when I think of, so the flip command is something that was created by the author, Alan Downey, for ModSim. So it's based on random number generation in Python. Uh, let's write down the syntax of the flip command. All right, and so here's something important. What does it mean to talk about the syntax? What does syntax mean? So syntax, to me, means it's what do you need to know to use a function correctly. So you'll need to know what is the input, if there are any, what are the outputs, if there are any, and how do you get from the input to the output? What is the rule that gets you from the input to the output? So basically, it's the definition of the computer science world. It's the definition of the function in terms of inputs and outputs. So whenever you're asked what's the syntax of a command, you need to be able to talk about, well, what are the inputs of the command, what are the outputs of the command, and how do those relate? So let's talk about this. We're going to talk about flip of p. All right, so you can see here that there's an input. This is an input. And so flip takes either 0 or 1 inputs. So you could either put in no inputs or you can put in 1 input. And so if there's 1 input, that's going to be what we're going to call P. Assumed that P is equal to 0.5 if there is no input. So when there's 0 inputs, we just make the assumption P is equal to 0.5. So that's the input part of the syntax, right? Let's put this. So the input part of the syntax is this. All right, what else? Now what do we say? And it outputs either true or false. All right, so this input gives out either true or false. So it takes in a number or no number, and the output is either true or false. So now, how are those things related? So the way that they're related, it outputs true with probability p, and false and false otherwise. Let me just write it that way. Okay, so this is the last part of this, which says, what's the rule that gets you from input to output? Well, you put in a number, and then it's going to output true with probability p and false otherwise. So it's either going to, so if p is equal to 0.5, then half of the time it's going to give true, half of the time it's going to give false. That's what this is saying. Let's run some code just to look at this. All right, so flip of 0.7. Let's run that. Hey, true. Oh wait, sorry, you can't see that. Haha, start over. Flip of 0.7. Run that again. True. Yay. Run it again. True. Yay. Oh, false. True. 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 False. Right? Every time we run this, it's going to give us either true or false. And it's giving us true more often than it's giving us false. Right? If we did flip of 0.1, that's saying that 10% of the time it should give us true, which means most of the time it should give us false, but you know, at some point it will give us true, on average 10% of the time. Let's see how long it takes us to get a true, false, 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 false. Oh, there's a true. Right? I think that was a little bit more than 10 times, but you should expect it to be a random process. You might even get two trues in a row, 3 trues in a row, but in general, on average, you'll get true 10% of the time, a flip of 0.1. All right, so let's go from there, and let's go back to our notes here, and let's talk about what happens if we want to model a coin flip. So let's model a coin flip. All right, and to do this, what we're going to do is we're going to use an if statement. All right, and this is one of those classic things from coding, which is a very natural thing. This is something that says, test, I'm going to give you a test. And depending on the test, I want you to do either thing A or thing B. Okay, so that's what's happening here. We have an if statement. So let's talk about the syntax of our if statement. We have, the syntax looks like this. If expression, colon. Ah, another colon showing up. What happens after our colon? We get an indent. All right, and maybe I don't want to draw my indent like that, but I want to draw my indent like this. If expression. So do this if the expression evaluates to true. And then an optional thing is, if you're not true, we can do an else statement. Else, colon, right? Notice we've left our indent and we're back to our line here. Else, indent, do this if expression evaluates to false. Right, and this is optional. Let me put that in a different color then. This is optional. All right, so if we're modeling a coin flip, then what we can do is we can say if flip of 0.5 colon print heads, else print tails. Right, so what are we saying here? We're saying flip the coin. Use your flip. And remember what flip does? It's going to give us true with probability 0.5 and false with probability 1 minus 0.5 or another also 0.5. So half the time, this part right here gives us a true. And when it gives us a true, it's going to point out a heads. But if it doesn't give us true, if it gives us false, then it's going to give us tails. So some of the time it's going to give us heads, some of the time it's going to give us tails. And then this allows us then to model the flipping of the coin that lands 50% on heads and 50% on tails. If you change the 0.5, you can make this a weighted die. Yeah, I shouldn't use that. Change the 0.5 to create a weighted die. All right, so let's go over to our code and run the code for this. All right, so here's an example, flip of 0.7, print heads. 70% of the time, it's going to print heads, and 30% of the time, it's not going to do anything. Heads, right? This right now. There's this else statement, and we didn't print heads because this gave us a false. Similarly here, if flip 0.7, if we use our if statement, we're either going to get heads or tails, and we're going to get heads 70% of the time and tails 30% of the time. All right, that's enough for today. I'll see you next time. Bye.